So I'm actually very happy to continue with this topic on the panel discussion, because it was also combined with the talk that we just had before. And one of the observations that we made is that the majority of industry applications that we see is mainly on fault detection. And also this is what we saw a bit yesterday as well. It's the easiest one to do. It's the quickest gains that we get. But the question is, what happens to prognostics? We do have some research developments, but we really rarely see it in real applications. And this is why we invited 4 distinguished guests and panelists to discuss this topic. And it's Professor Pierre Dersin, who has a kind of a double view on the topic. He has been very long been working for railway industry and has seen how this has been implemented. And now he is adjunct professor at Luleå University in Sweden. Then we have with us Miriam Rabacal from Canadeve Innova, who is a director of advanced digitalization, who has this view on this complex machinery monitoring and hopefully prognostics at some point. And she will give a talk in the afternoon. So you don't yet know what they're doing, but we will still get some insights into that. You know Erik very well. I will not introduce him. He already gave an overview of what they have been doing, and he has been introduced by the previous session chair as well. And we also have Dr. Bruno Santos with us, who is actually also a double viewer. This is really why I like this panel. So Bruno has been for quite some time with academia and has been doing research at TU Delft, has been full professor there, has been quite accomplished, and then suddenly decided to change to KLM to get his hands dirty again. And he is currently unit leader of data transformation and continuous improvement. And again, he will has this view what is possible in research, or what we are demonstrating in research, and what is implemented in industry, and what are the real applications. I ask everyone to prepare one slide to give us their perspective on the topic. But before I start with that, I wanted to ask your perspective before you're influenced by our panelists. And my question to you is, in your opinion, what is the biggest hurdle to adopting prognostics application in real world practice? So it's really your perspective, being it academic or being it industrial partner, being in the application field. So do you see prognostics, maybe there are no hurdles at all? So what is your perspective, or how to overcome the hurdles that you already did? So please share with us your perspective. So it looks like it's poor availability of data. Data seems to be a big topic. Concept, expectations. Sometimes it's cutting it in the middle. Sorry about that. Absence of trust in AI. You don't have to do prognostics with AI. You can also do model-based. So there is no excuse. Proof of benefits before starting. But if you do fault detection, you already saw the benefits actually. Reactive processes, inertia, value, maybe some are actually count. Adoption length is slowed. The issue, if you often don't know how the degradation actually translates in the measurements. Yes, so it's one of the research challenges, or that's a homework for us, but one of the challenges that we have been working on. People have voted for poor availability of data. Thank you so much for sharing your perspective. Some are still submitting. The benefit cost not easy to demonstrate. But it's actually the same is true for detection as well. So yeah, I think one of the biggest challenges is moving from detection to prognostics, and this is still where things are. By the way, guys, you can sit. You don't have to stand. There is still space in the audience. So thanks, and we will come back during the discussion, and maybe I will also ask the participants to comment on this as well. So we will continue with the perspectives of the panelists, and we will continue in the way that you saw the pictures appearing. So we will start with Pierre, whom I really asked to also give a perspective of the bridge or kind of the gap between industry and academia. So please, you can have the microphone.
Right.
Is it on?
It's good.
It's good.
Yes. Yeah, it's difficult to summarize all of this in 5 minutes, but I'll try to give you what is a very incomplete view. First of all, what is the state of the art? And in red, it refers to industry. And when it's in black, it's not necessarily industrialized. Then some examples, the hurdles, future potential, as I see it, and the enablers, what's going to make it happen. Now, first of all, you have the physics-based simulations, which are rather old method, and you have to understand the physics of degradation and so on. And there have been quite a few examples, for instance, in battery, state of charge, state of health, and so on. In other areas as well, the hurdle there is that you have a limited knowledge of the degradation mechanism and how they evolve over time. So the model is, of course, limited by that limited knowledge. Then the whole area of machine learning and deep learning methods, supervised or unsupervised. There are some interesting examples from Alstom, my former company, where it was possible in real time to adapt the locomotive axle force to environmental conditions and thereby to really save and to, in fact, enhance remaining useful life. But that's unusual. Now, in aircraft engines, there have been quite a few interesting applications. I'm speaking, for instance, about Safran, where they are able to individually forecast the trajectories of the engines and then take some measures to prevent failures. Now, there is a whole area of a hybrid approaches combining physics and machine learning, and such as physics-informed machine learning, for instance, leading to digital twins. Interesting example by Alstom, which goes back to 5, 6, 7 years ago, where they, by measuring pressure differential upstream and downstream from filters, it was, and using physical laws like Darcy's law for dust accumulation, it was possible to update the estimation of the remaining time till the filter is no longer usable. So that is really in fact, a good example of digital twin, but it remains as a proof of concept. Now, what are then there are a number of methods for RUL prediction. Those I see the most often in industry are simple methods like regression and the heuristic methods. Sometimes using stochastic processes like Wiener process, but has not been applied so much in industry. A typical example is a crack growth in structure. But then, as was outlined this morning, one key hurdle there is uncertainty quantification. And then you have a lot of methods that rely on images, including using images for physical things like wheel wear, comparing. And then one of the issue, not only for that one, is labeling. And then the whole area of health indicators or health indices. Typically, they are feature engineering based, so you need to have experts who design, who choose the right features. And then there are some more advanced methods like the one that was outlined, it was explained this morning, analytical HIs. And then the hurdle is the evolving degradation mechanism. As was explained this morning, the degradation is not constant, and you have to know when it changes. And other hurdles, you have the data which are often scarce, but sometimes you have too many data, but not the right data. So you have to eliminate unnecessary data. And on top of that, data are often heterogeneous. Systems are often not explainable. And then when AI is concerned, you have the whole issue of trustworthiness. And in railways, in particular, safety regulations are very important and come in the way of predictive maintenance because many safety certification methods are based on the assumption of periodic scheduled maintenance. And it's very difficult to have enough trust in the predictive maintenance to use that for safety critical items. Now, future potential. It's not necessarily, let's look at the whole column itself. Future potential, fleet-wide dynamic maintenance, typically in aircraft, in rails, etc., in turbo, in power systems. So you have a whole fleet of items, of assets, which may share a lot of commonalities, but are different. And the maintenance decisions ideally should be done at the fleet level. How do you take into account the asset-specific knowledge and knowledge of the complete fleet? Other future potential autonomous systems. Recently, the green light was given, for instance, in France for fully autonomous trains. Then, of course, space systems typically are, when you have a space probe in interstellar space, it's better to be autonomous. So then we come to the case where decisions, maintenance decisions have to be made autonomously, not just decision support. Controlling RUL. RUL, usually we use this as an estimation, but what about controlling RUL, that is adjusting the stresses so that RUL will be extended? And there are some people working on this, for instance, in Grenoble, and but it's not yet mature in industry. Then the whole synergy between images, words, and things. You can use images in order to understand system evolution, but the whole area of technical language processing, and there are some methods from language processing that can be extrapolated to predict RUL. That has been done to some extent. And then the whole area of large language models that can come into that. And reliability informed deep learning was explained in detail this morning. But what are the enablers, public or at least open access databases? We have mentioned CMAP. I wish there would be such similar database in the railway business and in some other industries as well. Synergies across industry. We see that different industries do not move at the same speed. Can some industry learn from other industry? And synergies between disciplines. For instance, one of my hobby horses, I think it's absolutely right, that RAMs, reliability, availability, etc., and PHM should be closer together instead of sitting in different departments, sometimes with silos. And so standards, now regulations such as safety regulations are hurdles towards prognostics and PHM in general, but at the same time, standards, in my opinion, would be beneficial, because when you can, in industry, when you can rely on standards, you are more at ease than if you break new grounds. IEEE PHM, by the way, standard 1856 is now being enhanced in order to contain more examples to make it more user-friendly. We'll see what comes out of it.
Thank you very much. Just hand it, or you already have. So we continue with Miriam, but may I ask the remaining panelists, please keep to the 5 minutes to keep time for discussions.
I'll do my best.
Thank you.
Okay, so starting maybe on the left side, here is just a picture on potential for prognostics. And on the first side is essentially a snapshot of the initiative or product portfolio as we have in Canadavia and with family products. And I put here the whole portfolio because the way that we see it, we see potential for prognostics in all of those areas, in both asset life in maintenance and also in asset performance. So the difference here that the first part is more focusing on equipment and extending life of equipment, whereas the second part is more about extending the performance of the facility, looking at the processes and optimization.
Maybe shortly mention what type of systems you're working with,
Yes.
just for others to understand, since they may not know the company.
That's true. So Canadavia is a waste management company, and we provide technical solutions, so facilities, industrial facilities that manage waste that is not recyclable. This may be industrial waste, hospital waste, municipality waste, and all of these different wastes. And technologies range from classical incineration, so transformation to waste from energy, steam and electricity, production of biogas, and we also then have, let's say, peripheral technologies such as carbon capture and power to gas. And so we build and operate these very big facilities, and these digital solutions focus on those facilities. I will explain a bit more later in the afternoon, so you can get a more clearer picture later. I also added here on these slides, I don't want to go into the details, but I find it very interesting where I go to meetings with industry networks and industry interest groups such as the VDMA, which is based in Germany, where they perform a lot of these surveys across a lot of industry players that belong to our members of these networks. And what I've been seeing there is actually linking then to the next part of the slides, is that there is this growing interest and potential in using Gen AI. So what I see, at least in my field or in the private sector, is that there is a growing interest and in the potential of Gen AI for these kind of topics, right? At the same time, the picture that I want to bring is that this is, at the moment, in my experience, there's also a huge hype. And I think it's important to keep, a view exactly like Olga was saying, solutions don't need to be necessarily AI. They can be model-based. Prognostics does not need to be based on the latest hype, right? And then the final thing that I want to bring here is that the reality is that we have these somewhat scary numbers, right? So we heard already about this MIT study. These big bombshell kind of studies on its own, each study will have its own limitations, and some faults. What I try to do here for these numbers, I try to combine a few of these papers and hopefully get an aggregation, but we still have these numbers which are not great, right? So 20 to 30% of projects will move beyond a POC phase, and less than 10% will be successful, creating a positive return of investment. Although I do not think that these numbers are necessarily, grim and this is dictating what's going to happen. I think it's just a wake-up call and a really important data for us to take a step back and discuss exactly what we're discussing here. So what are the barriers to adoption and how can we overcome them to avoid that this becomes reality for the future?
Thank you very much. And in fact, yesterday we saw that prognostics works in Erik's example, and that prognostics can be simple linear regression. And you don't need AI for that. So I'm curious to hear Erik's view on this topic as well, given that you have some working applications in place.
Yes, thank you. Sorry, I'll just stand here. That's a bit easier for me. So yeah, regarding the current state, I had the opportunity to, as Olga said, to show you a few examples yesterday. So where we see that the prognostics really gets into the field, yeah, and our results get into the field. This is especially true for the track geometry forecasting. We're also doing some things on component level condition monitoring. And then the other example I showed you yesterday was the anomaly detection regarding insulation joints with classification on top. So these things are, I think, well on the way. And here we tackled problems that were well defined, which is quite important, I think. So as for the future potential, if you ask our management, they always ask me, why don't you do it with LLMs? Can't the Gen AI do it? And I'm like, maybe I could, but why should I? I mean, if the linear regression is good enough, why not stick to it? But so I still have to find a problem where I can push it in for our management. But what we are really trying to tackle, and that's also something that Pierre just mentioned regarding safety in railway. Our safety standards are really, really high. Regarding the EU AI Act, we are regarded as high risk infrastructure. So we really have to set high standards, and I think we are not sure how we are going to get there. Yeah? So that's why it's important for us. Everything that we deliver is on top of the established maintenance processes still. Yeah? So we are always just talking about decision support. The decision is still on the field at the track masters, and that's important, and it's not going to change within the next few years. Of course, what the business case is of course the life cycle extension. We're also talking about the environmental and economic impacts. If we are able to use our scheduled or to reduce our downtimes, this also has an economic impact, which is quite nice if you are in the railway industry. One thing that I personally hope that we'll find are that we get new insights, especially if the models progress and we manage to get new parameters into the models. It will get us new insights and we'll develop a new understanding of what is actually happening outside, because there's still a lot of effects we see, we can measure them, but we don't actually know what's going on. Why is it developing the way that it is? Yeah, and for the future development, we're also talking about trust. So for us, it's important to develop human-in-the-loop systems where we are sure that we will get back feedback, especially in the early stages where we're still trying to enhance and get our systems better. So getting to the key hurdles, data quality, I think, yeah, that's one thing we all agree. We still have the problem in the railway industry. We are dealing with a lot of legacy systems. We are talking about organizational silos. So sometimes it's not clear why somebody should deliver data for another use case where he doesn't profit himself or herself. So that is something we have to tackle. Then again, trust, very important. We can use the best models that are available and the most input we can use from human resources, but also money. If our users don't trust our prognosis, then it's useless. And one of the really big key hurdles that we are tackling also in the USC project, in the Union of International Railways project, is scalability. So how do we finally manage to get from all those small proof of concepts that we have done, that have been lying around, how do we get them productive? And that's one big thing where I think we're progressing, but it makes a difference whether you try something on 20 switches or 50 switches and have to scale it up to 30,000 switches, or you're starting with some kilometers of track degradation modeling and have to scale it into a productive process that you have to monitor and you have to make sure that a model still lives throughout its lifetime. Yeah. So what is missing on the white space, I also wanted to bring in a graphics from The Economist. Welcome to the AI trough of disillusionment. I left it out, so I'm not sure where we are. I see we're going. Yeah, maybe we are through. I hope we are through.
Thank you very much. So we move. Yeah.
Yeah.
Bruno?
So good morning, everyone. Just a correction, I was not full professor, but associate professor, just to not to claim what I was not, but I'm happy to be here now in my new role and to set up the scene. This is a picture from our test cell in Amsterdam for our engines. So I work at the engine service at KLM. And a message that I have is that we can predict. We know that. We have seen here today, we have seen yesterday, we've seen in the literature. We can see also several applications cases in several industries. So we can do that. The challenge is how to make it owned, how to make it certifiable and adopted. And this is particularly the case when we are talking about critical systems like an engine. That makes it very critical. And what do I mean with owned? First of all, the problem has to be owned, and it's not always clear who owns the problem. Is the manufacturer? Is the operator? Is the MRO? Who owns the data? To be able to predict something, we need to have the data. That's where the power lies. Who owns the data? So that's a big challenge in the full chain to guarantee that we can have trust prognostics, that we can trace our decisions and our actions. Then certifiable. Yeah, we have to avoid black boxes because this will be hard to certify. The challenge is that we don't know how to certify. There is no process how to certify or qualify if we don't talk about certification, but qualification also not clear. So we invest in developing something without knowing what is coming next. And eventually we see years trying to qualify, and at some point it's pointless what we have created because the problem has been solved by the manufacturer. But also think about a certification not per algorithm or solution, but in the process, because things change. If I'm certifying a version of an algorithm, I use that algorithm, eventually I have a better version after a few months, or I have new data, or there's a change coming from manufacturer on that system, I have to go through the process entirely. So we should look into certification of the process of using predictive predictions in our process and not the algorithms. And adopted, we have a problem, for instance, if we use prognostics to replace components that is under a warranty contract. The manufacturer won't give us the new system if there's no really a failure end of life. So there's no point of removing that component because the manufacturer wants to see it fail. Also, industry has to get adapted to follow a new way of doing maintenance of aircraft and engines to be able to incorporate these prognostics. And this is also about skilling up our people, also knowing what does it mean. It's a different mindset. We go from deterministic to probabilistic. How are we going to incorporate that in a complex world that we live in the aviation? And then critical systems become critical because we almost don't have, or we don't have at all, failure data because we don't let them fail. So that's a problem, what we're going to do there. And the safety standards are super high. So we need to guarantee with 99.999% guarantee that we won't miss a positive signal. So in a little bit teasing conclusion of my pitch is contrary to what we heard yesterday, very nice in the Luminary talk from Marcus, that even for critical decisions regarding our health, the AI does better than the experts in the field. I don't think that we will go, is this the one? Is it okay? But anyway, if we see complexity problem, complexity can be related with safety, data, complexity of the system. So complexity in general, I think that we are limited in what we can achieve with AI, and limited because we don't want. We want a human there because the trust is not there. Because we don't need it. We have experts that can do that better. So our focus there should be more in supporting, having critical agents supporting the decision and inspecting what they are doing. In the beginning, so low complexity parts, there we should look at the automation. Please give time to my colleagues to work on what they are good and what is repetitive, easy to solve, just solve it in an automated way. And then our focus should be in the middle, where there is the big value. Is supporting non-critical systems in terms of prognostics, is predicting my inventory, is predicting my flow in the shop, is giving a good idea of what I need to do when I'm looking for an answer in a 1,000-page documentation that I have to rely when I reply to my technicians what they need to do. So that's where we need to invest our time. And final word is a line, I think, with what my colleagues also said, simple is better.
Thank you very much for these perspectives. And so please, you can still submit questions and discussions. We'll also give you opportunity to participate as well. I wanted to start with a question that actually most of you have touched upon. And this is one of the challenges, seems to be one of the challenges in the industry. How do we move from proof of concept to something that is scalable and that's really applied and bringing value? So since most of you have experience in that, how to do that. So which advice would you give to those who are in the earlier development stage? So what is has been your secret to achieve it? And what did you learn as well along the way that you're now replicating in other projects? Who would like to start? Sure.
My experience for 1.5 years at KLM, so I'm not the most experienced here in the panel from that side, but first of all, it needs to solve a problem and doesn't have to be an innovation per se. So it has to be there to address a problem. Needs to have a business case behind, because without business case, there is no support, and involve stakeholders since the beginning, users, but in our case, also regulatory entities to make sure that we are not shooting into the dark.
Thank you. It's a nice summary. Erik, would you like to add maybe, since you also move partly is still moving? So what were your lessons learned?
I think one of the key lessons was also what you just said, to keep it simple, take a problem that is clearly defined, well-defined, and this is not easy, because like on my team of data scientists, and the excitement always is a few steps ahead, and they're already seeing the next things they want to tackle. So we really have to sit down and make sure that we just tackle one small piece at a time. Then taking in the users early. That's also one big lesson we've learned, I think. But not only the users, also the people that have to manage the system afterwards. So we need people from our IT departments. We need somebody who is doing ML ops afterwards, to also see what kind of danger we are running in if a system that we establish, as you said, it won't stick to the one model you have, but you want to enhance, and then what are all those processes that you have to deal with later on? And then for the railway industry, everything takes longer as expected, and I can tell you from my own experience, things that run on desktop computers in the office, scaling them up to some powerful hardware. It took me 3 years to get hardware acknowledged that is worth, I think, 80,000 euros. We're not talking about the business case. The business case is not the problem here. I don't know where the problem is, but yeah, we've solved it.
Finally. Miriam?
Sure, I will essentially repeat the part of the problem statement. At least my experience has been in my company is that POCs that fail to move are the ones that had an insufficient problem statement. And the problem statement will include technical, organizational, operational, all of user, right? All of these aspects. And what I noticed, even myself, right? We are an engineering company, so we love to jump into solutions. We love to do it before having a good understanding of the problem statement. And so we have to really not jump into solutions and really go through this process of having a good description of the problem statement. And so those POCs that have this good description are usually the ones that move forward. The other thing that was really important for us in Canada Via, my team really started this whole new product line, right? Together with product management and other disciplines. So we had to, build all of these things from scratch, MLOps and infrastructure and so on. What was really helpful for us is just learn from pioneers and from the best. Later on, I will explain a big inspiration for my team has been David Scully, which has been a guy that really was a pioneer in MLOps in Google 10 years ago. He developed really excellent frameworks that we use today. We took those frameworks and we adapted to our specific circumstances in Canada, and we use those frameworks in order to help us and guide us through the journey from a POC to a live product. And we do have products in production, and this has been very, very helpful for us.
Thank you very much. Pierre, would you like to add? Because usually in academia, we stop when proof of concept has been shown, and this is when we leave.
Yes, yeah, there's the notion of technical maturity that yeah. But I think the key for scaling up is process. In very regulated industries like aircraft, aviation, or railways, there is a process to, at every step in the V cycle, you have so-called process reviews, and you have to show that a certain number of measures have been taken. And once PHM is integrated in that process, it will become automatic. I mean, design for PHM is key. And today, a proof of concept, okay, it's something like innovation, but it's something outside the process to prove that something might work. So the whole effort now is to move from these isolated experiments to something that is integrated in the process. And this is what the IEEE PHM standard is trying to do. If you look at NASA, or if you look at the US defense industry, for instance, they have some requirements for PHM at the design stage. And if you don't pass those, don't fulfill those requirements, your product or system is just not accepted. So by the time we move to that situation, it will no longer be considered an experiment or something for a, but it will be just part of the regular process. And I think that's the main challenge, in my opinion.
Thank you very much as well for adding this perspective. And thank you to the person who asked the question, because actually this was the question that I anyhow wanted to ask. So thanks a lot. It was also a question that was asked yesterday as well. One of the challenges that we have in the field of predictive maintenance, how do we actually define business cases? So how do we quantify the impact of what we are able to achieve? Because if we don't have failures, we actually don't know how much we have avoided. And Bruno, particularly you insisted that we should have business cases. I agree, this is how you convince your management, but how do you create business cases on something that is very difficult to quantify?
Yes, it is difficult by default, but to be clear, we don't have any business case for critical systems because we cannot allow prognostics to get in. So we only talk about non-critical systems. So usually are systems that are maintained according to a reactive mode. So we know when they fail. So our business case relies on the fact that we're going to repair them before in advance, avoiding some mostly operational costs. So this disruption costs that Manuel mentioned during his presentation. So it's about eventually the life that we lose from the component. That's really a cost, and then the benefits of not having to bring the aircraft on a rush and disrupt our network. So based on those type of estimations, how much are we gaining there? Then we make the business case. Eventually, for other parts, we can, or for some parts, we can also look into the cost of the parts and how can we negotiate that with a manufacturer. So we usually work together with Boeing and GE, our main engine manufacturer, together also to get the business case on the part of getting cheaper parts. Yeah.
Thank you so much. I think for every business case is solved, we don't ask you. it's in the order of billions. But we ask Miriam, how do you quantify the benefits?
So usually this is an outcome of the problem statement. And we usually have, let's say, different perspectives as we learn more about the problem. Usually when we start, we will try to understand this kind of monetary benefit, right? If I would predict these situations, or if I would be able to solve this situation, I would have created this kind of value. For us, we're able to collect some of this data because when we deliver a plant to a customer, and for the plant, especially during warranty, we will collect all of this data and all the and all these failures and so on. So we have good statistical data that we can use in order to make hypotheses, right? But again, this is very hypothetical, right? We start with a hypothesis, which is if we are able to predict this, we will create this monetary value. But as we go into the problem statement, which usually requires, user research, a bit of research about the environment, so on, we start to learn more about it. And more often than not, we realize that there is a lot of value, not necessarily just on this, if we avoid this particular failure, but rather if we're able to provide a solution that changes the way that people work in a more effective way, you'll get also a lot there. So actually, as we develop the product, as we develop the problem statement, we realize that the business case is beyond this short hypothesis. We're now doing actually that exercise for predictive maintenance. We still don't have results for that, but this framework has been very helpful for us to create the business case for asset performance products, which is what we have now in the market.
Sure,
Can
go
I just
ahead.
add something? Yeah, no,
sorry if I
no,
did
no,
not
no,
give
no,
you the
don't
word.
worry. No. One thing about business cases is that we had to tell our management that it could fail on the way, and I think that that's something our management had to learn. Yeah, that I'm happy for the money I get for our predictive maintenance use cases, but as well they are we try to define them quite well. Yeah, but still there's the chance that we don't get anything out of it, yeah, because the data is not good enough, because the models don't work as expected, yeah, because we can't get it into a running process. I think that's something we really try to show very transparently to the management to say, okay, this is the potential we're seeing. It's huge, yeah, but there's certain gateways we defined where we say, okay, if it doesn't work, then we have a way out, and the management had to agree that. Yeah, we learned something on the way, but maybe there are some sunken costs coming along.
Thank you very much. So Pierre, you were actually one of the pioneers to push PHM into real applications. Did you also see a change in acceptance and how much you needed to invest in convincing? That's at least what I have been seeing, but what was your perspective in terms of that?
Let me say something more general to come back to your question. I think the business case depends on two things: where you are in the supply chain, and also what is the business model. If you are a supplier of a piece of equipment and you are just paid by the number of items you sell, there's no incentives to do PHM. If you are an operator of a railways, for instance, and every time there's 1 minute of downtime, it costs you 1,000 euros, then you have a big incentive. But how do you pass on the benefits to the suppliers? That depends on the business model. In the old days, the business model that we sold trains, and people said, well, if the more failures we have, the better it is because we sell spare parts. I've heard this. So people who said this have been retired for a long time, unfortunately. But then the situation now is that you have more and more service level agreements. You can have to pay penalties for 15 years or more if you don't achieve the right availability. So if you pass on those penalties to your supplier, then the business case is almost obvious. The question is, it's a question of negotiation between the various stakeholders. So to answer your question, yeah, I have seen evolution in the 10 years or so towards understanding these relationships between the stakeholders. But unfortunately, at the same time, I've also seen a lot of over-enthusiasm and inflated expectation from management. Say, oh, you can do this. Okay, come back in 1 month and show us achievements. So typically that doesn't work, and that creates a backlash. So there are those two trends.
Thank you so much. And actually, while you were speaking, someone was just asking this question: how do you manage the expectations of this hype? But it's actually also related to another question, and all of you were mentioning that involve involving the stakeholders early on in the process was key to the success of the projects and moving it into the production as well. So how do we actually increase the readiness of the users and really get their acceptance as well? How do we educate them to the level that they can use it as well and are really active participants but not just trying to not use the tool or objecting the tool? How do we overcome this challenge? Any advice of the projects that you did successfully or learnings that you had along the way?
At least what my team did was, again, looking into people that really know how to do this and implementing really systematic UX methodologies. It's not a new field. It exists for a really long time in consumer-driven industries, where you also have this issue, right? Where you are essentially transforming the way that people interact with a certain product, and how do you do it in a way that people are open to this change, right? And so this is something that actually we first start doing with externals, but then we realized that this is super important, and we started building a UX team internally, which is a super important team during the problem statement. And what I would say that from this field, the really important aspect of it, or the key aspect, is when you are talking to your users or stakeholders, that you have a discussion, not pushing a solution or a technology, but you're having a discussion of understanding what is their problem. And they are the stars of the show. You are there just to ask questions. That's it. And then you take all of this research with you, and then you have to find ways of building something that actually fulfills the problems that they have. And by the way, again, users will, because they are engineers in these discussions, they will want to start talking about solutions. You hear them, right? They need to feel heard, but you focus not on the solutions that they propose, but again, on the problems that they are facing.
Thank you so much. Erik, would you like to add? Was it similar experience that you had?
Yeah, I completely agree. It's also from our experience, it's very important to see what the actual problem of the user is, and to help them to define the actual problem, because often they don't even know. If you ask them, how can we make this better? Then they are talking about colors of the, but it's not solving the actual problem that they have in the process they are walking through. So I think this is very important, and then we try to in the backlog we have, we try to prioritize projects where our users have a huge benefit, which might not be the same projects where we see a huge business impact, for example. So we always try to deliver projects to both sides, basically.
Thank you. Bruno, any different experience?
No, just to add, because I agree with what has been said. This also, I think it was implicit, but to mention that also have the users as being part of the team that looks into the solution. So not just take them their input and then come up with a solution, but also walk with them. And we use an agile way of working where we have several feedback loops with users and think with them what could be the solution. I have a particular challenge in my case. The population which I work with, the average age is almost 50 years old. So people that are more looking into the retirement than really upskill and look into other type of technology. So usually there we have to, in each team or users team of the problem of what we are trying to build, we have to find 2 or 3 champions and then try to work in a good solution, try to use those as champions. And what works is then at some point we really have to phase out the other process, because if the 2 stay in parallel, it will die. So we have to phase out and implement a new one.
Anything to add, Pierre? Has been
No,
was agreeing.
I agree with everything, but in 1960 there was a paper in the Harvard Business Review called User-Driven Innovation. So this idea is not young, is not new, but to make it happen in practice is very difficult because sometimes the relations between the companies and the users is a client-supplier relation, and it is not always conducive to trust. So basically, part of the success in this innovation, it may be a platitude, but rests on the trust, not trust in technology, but trust between the stakeholders. That's key.
Any question from the audience? Yeah.
Sorry, so this question might be directed a little bit more at Pierre and Bruno. So obviously there is a mismatch in incentives from the academic perspective. For example, you're highly encouraged to reinvent the wheel at every opportunity that you have, and frequently it is not well seen or is deemed as not enough for you to use a regular, well-known solution applied to a problem. Instead, we have this incentive to keep on innovating, even when this is sometimes either unnecessary or actually damaging. Do you have any advice on how to go around these limitations and somehow keep, feed into academic prestige, which is something that we have to feed into, obviously, but at the same time, keep your work relevant to industry?
Thank you. It's a very difficult question, but I can just start with a concrete experience we have at Luleå Technology University in Sweden, where we work a lot with industry. We have a thing called Artificial Intelligence Factory, and we work with the mining industry, the rail industry, the aircraft industry. And of course, what they expect from us, nonetheless, is to understand their problem, but to come up with innovative ideas, because usually, I'm saying this with caution, but usually they don't have time to innovate because they have the head in the grindstone. They have to solve short-term problems. So they welcome this innovation, but at the same time, this innovation must be guided by their needs. So I think that one of the answers to that rests in the closer relationships between industry and university. That doesn't mean that academia should stop doing innovation, but maybe academia can have several levels. One is long-term research, which is necessary to progress, and the second one is more applied research in conjunction with industry. I think that maybe some others.
But maybe just to add, sometimes industry is not willing to look 10 years ahead. I was discussing once with an industrial person, and then I was trying to excite him about an idea, and they said, "Oh, this is 10 years ahead.
Yeah,
we will not even start hearing about it now."
Well, it depends on which industry and how industry is organized also, because the answer is not only from academia. In industry, you have some research centers or strategic units that look 10, 20, 30 years ahead, but it's not true in every industry and not in every industrial company. Yeah.
I'll take one more question.
Thanks. So I'm trying to open my mind by being here. So I work in a chemical industry making materials. So it's a multi-purpose plant. So we have lots of 1, 2, 3 cubic meter reactors. They probably have recurring problems. I don't yet know what they are. I've been there for about 1 year. And what I hear about is a lot about trains, planes. I mean, they're very large things that really cannot fail, also that have people inside, right? But I was wondering if an industry like me, or like the one I work in, is interested in starting to apply some of these tools that we hear about. Have you had interactions with people from those industries, and do you have any tips for me?
Maybe Miriam is the closest.
Yep. So the way that these plants look like, these waste management plants, are essentially a combination of reactors, pumps, conveyor belts, and this kind of stuff. So I think there will be a lot of similarities with chemical industry. And so I think you brought a key aspect, right? Is understanding what are the problems and or what are the issues and quantifying them as much as possible. And so I was mentioning earlier, when we come up with a value hypothesis, this is usually always data-driven. We go into our availability registers, and they might be super messy. That's just sometimes the reality. Sometimes it's emails chains, is not super clean, but we spend that time. And we believe that it's important to invest this time to go in through these registers and understand and quantify problems. And then when we make decisions about prioritizing, because you cannot do everything, right? You cannot go in and attack all the issues. You might have some of the angles, maybe the business case impact and so on, but the other one may be actually how well can we quantify the problem. And so we typically would also prioritize those topics that our hypothesis is the strongest. Because if your hypothesis is very weak, there's a very likelihood that it will not work.
Thank you. And also thank you for being here to opening your mind. No, but I think you're not alone. I realized that having 1 hour with the 4 of you is actually not sufficient. It's really very insightful what you have been sharing. And we will have sufficient opportunities for others to ask you questions as well, when some already did that. And I would like to close with a question to all of you. And my question is, what are you currently most excited about? And what makes you most hopeful as well about the future, about the next years that are in front of us? Would like to start? Maybe we can start in the middle. We can start with Erik this time, not on the edges.
Okay, thank you. So what makes me most excited at the moment is I think that we've established a very nice network within also with other infrastructure providers in Europe, where we can learn a lot actually. So that is maybe the outside framework, where I really feel that we have a spirit that we develop, and we see that we can move things, and we see the traps that others have fallen inside already, and so we can try to avoid those. And from inside my team, I think I have a very good combination of people that are not only willing to develop new ideas and develop new models, but also help to get their hands dirty when it goes into productionizing things, because that's what it is. It's a dirty business sometimes.
Thank you so much. We continue maybe with Bruno.
Yeah, sure. I'll be short because I'll invite you to attend my presentation in about 1.5 hours, and I'll mention a few projects which I'm excited about.
One thing.
We are using voice to text to speed up the inspections of our engines.
Okay, thank you so much. So keep tuned, Miriam.
So can I say two? So one is just very easy. We have focused a lot in asset performance, and now we're moving into asset life, meaning that my team is now really putting focus in maintenance and predictive maintenance. So that's really exciting, especially because I know there's a huge community. There's a lot of people doing great work. So I'm excited about that. And the other one, which is, I'll be short, is that we've been very good at, deploying these isolated products within this portfolio, and we're now starting to integrate them in a portal where you then start, as a plant manager, you start then having a complete picture of your plant, and that's very exciting when you combine the different tools together. And I think there the outcome is bigger than the sum of the parts. So I'm also really excited about that.
These are two very nice ones. Pierre? You started and then you conclude.
Yeah, just a general remark. What makes me very enthusiastic now is the trends towards synergies between PHM and physics informed machine learning, for instance, synergies between PHM and reliability, synergies with material science, etc. So the fact that this theme becomes integrated with a number of very important disciplines, I think is a good sign. And also another good sign is that I see a lot of talented young people who come to this area instead of maybe going to finance, where they would be paid a lot more. And so I think we need this energy and this enthusiasm.
Thank you so much to all of you. It has been very insightful. Thank you for sharing, and really very good. I could have discussed with you much, much longer. Thank you so much.